Hola, hola. ¿Cómo están? Buenos días para todos.
Hello. It's a pleasure to meet you all once again in a face-to-face event after 4 years. It's a special time, a special event with many news, AI, super apps, but no. What I mean is that this is the first event with a Christmas tree at the door. It's the first event that I have my daughter here in the floor. Don't. She'll die away. But before starting, I'd like to say something clear. I don't like talks when the presenter makes a question and ask a question and the people have to raise their hands. I feel uncomfortable, but because of the dynamics of this talk, I'll have to do this. So I'm sorry if you feel uncomfortable, but please help me and collaborate. Now, this is a photograph that I took at an event I attended this year. It's an event of the Java community in Belgium, in Antwerp, DevOps. Many interesting talks there. And I asked to please raise your hand if you know the old man here. I mean the tall old man. 2, all right. Well, that's not that bad. This same question, I asked it when I sent this photograph to a couple of friends of mine, and I asked them, I said, look who I am with, they are going to tell me yes, wow, wonderful. 90% said, what are you doing with Father Christmas there? So if you think, those of you who raise your hand think he's Father Christmas, he's not. Now, I have a very good friend of mine called Alejandro Triaca, and we call him, he's the master of Photoshop, and he sent me this photograph. And it's you in the future, he said. Well, that's the way of showing how we love one another in our WhatsApp group, even if you don't believe. Perhaps you have a similar group. The way of showing our love is like that. But okay. Why have I shown, to start my talk with this photograph? Well, that person, I asked him who he was. He's James Coslin. He's the father. He's Java's father. And the person next to him is the father of Franco and Sol, Sol is there. So I wanted to start with this photograph because this photograph speaks by itself about Java. We're going to talk about Java in general and the Java generator in particular. The first part, we're going to divide our talk in 2. We're going to talk about Java, and then in the second part, we're going to talk about Java generator. To talk about the first part about Java in general, I thought it could be interesting to go over my personal review of what I think were some of the most important landmarks or milestones that turned Java and what it is at present. I'm not going to be talking about features in particular, but I'm going to be talking about events that happened in Java's history that shaped what Java is at present. This is my own these are my own milestones. Probably you may have others. This doesn't apply. I would put in something else, but this is a short talk, so I put in what I thought was important. Of course, when you talk about important milestones, you have to start at its birth. And in 1996, a working group led by James Coslin, the person who was there on the photograph, was working with Sun Microsystems, and they released this program in language. I thought it was interesting to put the year. It was 1996. It's almost 30 years since it was released. And I think it's very important for the IT industry, where everything changes so much. Program language goes on being there. So that means that something was done correctly all along that year. Now, when he was asked what Java was for him, he was asked to define it when he released it. And he said, Java is C++ without the guns, clubs, and knives. To me, those who know who C++ is, I think it's a wonderful sentence. I think it's a typical sentence that we nerds like to print on our T-shirts and look how smart I am. No one understands what is written on the T-shirt. Now, right from the beginning, Java started with this sentence saying, write once, run anywhere. That's the classic or it changed the way programming language existed. It was a typical machine language, and they had another vision. The source is compiled with a bytecode, and then during the execution time is interpreted with a Java machine, and then it is compiled with the language machine. And the machine can change according to the device I'm going to run it, so it's multi-platform with the same bytecode in different platforms. Now, we're going to talk about the various milestones. We are in 2006. We moved 10 years ahead, and this is one of the important milestones in Java history where it was decided it was going to be an open source, OpenJDK. And it's important because right from the beginning, Java had a very much engaged community, a community that was very much involved with Java's development, and we're going to see how along its history it participated in many milestones to become what it is at present. In 2010, before that, Sun started seeing that there were some financial problems with good products but can't be monetized, and it looked for someone to buy it. And so it had quite advanced talks with IBM, but it didn't. And then Oracle jumped in and made a juicy offer for all its protocols, and that's for its products, and that's why we have Oracle acquiring Sun Microsystems. And it also acquires Solaris operating system, Spark machines, and so on. It expanded. Of course, this is a very important milestone. It's one of the largest market players. It approached Java to the entrepreneurial environment, and it also provided lots of resources so that it could continue doing research and development. Now let's move on to 2014, where we have Spring coming up. Spring Boot emerges. It's a module of a framework called Spring. It's an open source framework, and the module promised right from its beginning that it's going to facilitate the developer's life. So far, entrepreneurial apps were made using a standard called Java E. It had been called Java 2E, then Jakarta, and so on. And it promised an abstraction level on top of that. So it says, don't worry about this. I propose a higher abstraction level. Don't worry about configurations. So far, they were quite complicated. We're only going to have one file to configuration, and I'm going to give it an embedded server, so you don't want to have to do anything, and that's it. So this module, you have Trump Shetty embedded, and you could package everything in one hard and using it, running Java and the hard that you had packaged and without installing anything else. Now this is a graph of how, right from its beginning in 2014, it started to run, and in orange it was called Jakarta E or Java E. Spring Boot and Jakarta were the names, and you can see how Spring Boot started moving up, and there were other frameworks with the same idea. And so in 2016 we have Quarkus, and it also exceeded Jakarta, not that much, but it did. at present, it's quite difficult to see an app started by hand, not using some kind of these frameworks, Quarkus, Micronaut. We're going to see that some of them are very used. 2017 to 2019, we had a transition that produced quite a lot of noise in the Java community. As I said, up to then, apps were using Java E for entrepreneurial apps, and Oracle realized that it couldn't make it as agile as required for that specification to go faster and include more features, that it was in a company that had a certain bureaucracy and red tape that wasn't making it as agile as it wanted. And so it donated Java 2E or Java E to an open source foundation. And it was then that after looking around, it donated to the Eclipse Foundation. These are some of the apps, of the APIs that, if you know what Java is, these are some of the APIs that Java uses and that are defined in Java 8. Servlet, Java Mail, JAX, EJB, etc. They were going to donate that to the Eclipse Foundation to follow it up, but then there were some legal issues coming up. Now that they had some legal problems with the name of Java with Google, and so it was decided that that specification couldn't be called Java E, and so the community voted, and they voted, and it was called Jakarta E. That's how the name changed. But the main problem was that all these APIs started with Java X, and that also had to be changed, and that's how they changed it to Jakarta. Now, that meant that everyone having written APIs, written apps, had to change it, and all new servers that are implementing this API so that they can run the code that you write also had to change. And that's how, when they changed from Tomcat 8 to 9, and if you want to run it in Jakarta, in Tomcat X, you had to make all the changes in the code, changing all the packages, and that was quite traumatic for the community, and up to now it's still hitting hard. In 2018, Oracle decided that it was going to distribute its updates in a shorter time. So far, the distribution was from, every 3 years, from 8 to 9, and put in lots of features, but the update was in 3 years.
Started releasing versions every 6 months. And every 3 years, they would release the support versions, and the intermediates would only get 6 months. And then, after Java 17, they decided to do so every 2 years. At present, 4 Lantern support versions coexist. One of the latest was released 2 months ago. So what was the result? People were able to get the versions faster. If that was fundamental for the customer, the change, the new feature could be adopted right away. And there were less things to be complicated. In 2019, Oracle surprised the Java community with a hard blow. It says, after an upgrade of Java 8, Java will no longer be free of charge. If you want support, you will have to start paying a business license. And as from such and such a date, if you don't pay, no support, or move to an open JDK version. This was what Sun created when they declared the open source system. So the community was surprised. Some decided to pay the business version, or others moved to the open versions. Fortunately, there were several OpenJDK versions in the market, and here we see some of them, some belonging to Microsoft or Amazon or Eclipse and so on. This screen is like the Bible today for the Java people when they need to use a Java version. Which OpenJDK version will they use depending on the environment where it will have to run? The most recommended one this year is like Xamarin. This is the current situation in the use of JDK. And the Oracle one is declining and will continue declining probably. Then we'll see why it did not decline so much. But for the time being, we'll keep these figures. We see a good growth of the Amazon one and the Xamarin also. These are mostly used. Why is the Amazon one so high? Because if we want to run a Java application on the web services of Amazon, Amazon uses its own OpenJDK. And if you want to use it, you can use it. That's not a problem. You don't need to use the JDK within the Amazon website. In 2019, we have a new development led by Oracle, supported by the community. It's called Graal VM. It brings native images among some new features. It focuses on performance, tries to have quick executions. It tries to have different carriage collectors to be more agile. But the main thing is what it does with native images. Native images change the concept of have a vector machine that interprets the code and it translates it into machine language. This is a time compiler and changes the paradigm. It's ahead of time compiler. I will do it in time compiled, but I will collect all that is necessary. This will give me higher speed. From the start of the virtual machine, I will use less memory and I will work with smaller packages. Because this alternative says that in the compilation time, it will review the code, check where it goes through. You know that Java, if it has to use a little bit of a library, gets it all. So now this package is choosing only what it needs. So it saves time and space. Am I going too quickly? Yes. So, what do I get with this? These three things. I lose one part because the time compiler has some advantages when the same code is executed several times. It has two internal compilers that do one run first and then another and several runs as it collects the code and sees how it can be optimized, and it's getting better and better. So in the long run, it has better response times. But if I want to execute something that's very fashionable today, what would be the advantage of RBs? It executes and then dies. The just-in-time compiler was not good at that. It had to collect the whole thing and then realize, using a lot of memory. That's a good option when you want to execute something that is simple.
Ejemplo de cómo la misma aplicación se corre.
This is an example that we have in, and this is what we were mentioning in the beginning. It gets information, executes, and then ends. And the starting time is 20 seconds, approximately. it is less than 1 second, and the amount of memory is much less in this option when you use native images. Now, the problem this poses is that it needs to know the whole code. And in the code, sometimes we have reflection calls, and we do dynamic calls. And at that point, when we compile, we need to help the compiler mentioning all the reflection possibilities for the reflection call. These are the ones. So the machine knows, includes this, and it's ready. In 2021, Oracle realizes they made a mistake. When I decided to charge Java, that was a mistake. Now Java will be free of charge again. And you may say, well, as from Java 17, everybody will use the Oracle JDK. No, that did not happen for several reasons. First, because people got used to using the open versions, and they worked, and then said, well, you change it once, maybe you will change it again in future, so I better stay where I am. And a third interesting thing, remember the whichjdk.com page? It says, whenever you want to use the Java version, call your lawyer because the license is not clearly worded. Well, the lawyer could be a chat GPT today. So you may ask him, and he said, yeah, go ahead. Who knows? Well, 2023, a few months ago, there was a release of Java 21, the last one with support, with an emphasis on performance. They worked a lot on executing faster. It provides a new garbage collector, which is more efficient, and it releases many new features like the one I'm going to explain, called virtual threads. In the past, it was called Loom Project, but now Java, as it develops something, it gives a name before releasing it. It's a different name. It's called now Virtual Thread. It was present in previous version, but now it's released with the name Virtual Thread. This allows that in the operation system you can execute different logical processes as user. When we work with a server like Tomcat, which has a pool of threads, all requirements come to the Tomcat. They get a thread from the pool, uses it all the time until the execution ends. And then they realize that during the execution, there are many layoff times in quality, in sharing resources. So what they did was take advantage of all that and execute the same virtual thread in real executions. This is what virtual thread does. It uses less resources from the OS. You don't have to have a pool. It is done automatically. It realizes which thread to go into. And with this, the advantage is I don't have to change my programming, my current programming. Everything will be done automatically if I'm using Java 21. This is the type of thing that different versions of Java provide. It has features. If I don't change the generated code, I cannot use those features. But it has many other features that will be automatically there. They are part of the new execution. So it's always good to upgrade the Java versions to enhance your performance and also other features. In this case, we could use the virtual threads simply by updating Java 21. So far, I told you about the way in which Java is still relevant in the business sector. It competes with eJART And also in the serverless environment, Java was not well considered because it took long, it used a lot of memory, and so on. But Java now starts competing. And in that competition, Java has an asset. This is a report from a page. The source is mentioned there. It studied the different programming language to see which consumed more and less energy. And this is very important today. This is green computing. So Java is at the very top. And if we compare with JavaScript, it's slower, and Python has 75 vis-a-vis 198. If a friend tells me I'm working with Python and say, no, we have to cut so many trees for you to use Python, use Java, and I send him this list, they never answer back. Well, so far we've seen the most important landmarks to get to the current state of the art. Now I will talk about GeneXus. Maybe you're bored stiff with all I said before, but I'm not going to mention all the landmarks of GeneXus because that's never ending. Java Generator was released in the year 2000. It's 23 years old. Why do I mention it? Because it's been in the market for the last 23 years. It must be very slow, you may say. No, it has been updated. We added new things. We improved the layers, the generator. We changed versions of different libraries. We added the web generator. But also the web generator will have to be removed in future, and the Java generator will be a backend or services generator. Now I will mention other recent landmarks. This is not very recent, though. GeneXus 16U4. I want to mention it because it's relevant. It's getting late. I understand that it's relevant for those of you who do not know it. I will go faster. Please don't, because it's crazy. When I practiced, it was 22 minutes, but now I have to go faster. Well, this year we released the standard classes of GeneXus in GitHub. You can download them, read them, compile them, modify them manually, and easily compile them again. And so far, you cannot do EQ request. You cannot do that at all.
Para que me lo aceptes.
Now, we do have that if you find something and if you like to play there, you can communicate with support and say, well, I found this and that. We can study it and we can change it. Things like that have already happened, and it's easy to do. Now, we've added what I told you about GeneXus 17U5, the Java X versus Jakarta. So we put a Java platform which is configured automatically without realizing what Tomcat you have, whether it's 10 or higher, and it's only for Jakarta, or if it's lower, it's just for Java E. And there, depending on the production environment, you'll have to choose one or the other. And also the standard classes changes. One is for Jakarta and the other one for JavaX. We also have a platform, an option of if you have a project that requires running in the two versions. In the case of GAM and Workflow, we did only one that can run in the two. And in that case, with the post platform, and it generates two notations instead of one. And when you get it to production, you have to choose where you want to run it. This is one of the most important changes in GeneXus 18 and was the change of build. And this is the change that is bringing up the hardest debate, but I can explain why we did it. Now, when you work with Java in the community, you have two mechanisms to make build, which are native, that people use, Mabel or Gradle. And that's the way you compile and you make packages in the Java community. We chose Gradle because of many reasons that I'm not going to explain now, but basically we chose Gradle because we thought it had a higher potential, it was going to be more useful in the future, and we can use in Kotlin or Gruin, and that's good for some things that we want to do. Now, before having this build system, we were doing all the compilation manually. We had a .NET process where we would basically go over the faces that change and the compilation date one by one, and we would set up a list of the things we had to compile, and we would pass on that list to Java-C. If it wasn't too big, we would divide it into modules, and we call it and we called Java-C as many times as the times we had to compile. We couldn't go on doing that. We couldn't evolve. We couldn't use many things that we're going to see in the future that we are using. With that mechanism, we couldn't do it, so we had to change it. And we changed the Gradle mechanism. That made us make other changes. We changed the structure of directories where the sources are generated and where the sources are compiled. We used to compile, generate, and compile all the sources in the same folder, in the same web folder of the model. Then we have another one, Java main, which is a standard for these tools, and the compiles are in other place. We stopped distributing GeneXus libraries, the external libraries. We would do it with a generator. Now we can set up our standard classes. We can publish them in a Hearts repository and download it automatically when I make build. And I'm going to download the Heart only one, the ones I need, and it does it on its own during the compilation time. We added a property which is quite interesting, which is the property that allows you to say what versions of the standard class you want to use in the version you are executing. This comes by default, and it's fixed when we distribute a version of the generator. If you don't touch anything, you're going to use it all the time. But there are two things where you can use this property. One is when you want to obtain a hotfix of the standard classes, when you reported a mistake, an error. So we would correct it, but you said, I need that hotfix because I can't change. And so now you don't have to download the entire GeneXus to obtain it. You go there, you put in the new version of the standard classes, and then in the next build, Gradle will do it everything automatically and starts executing the new version. The other useful thing, as I said, when we were publishing the standard classes, was to build them, make a little change, test it, and you end up by setting up those classes. And so you can make a Gradle and install, and it's published in a local Gradle in your computer, and then you get a little number there of that version, and it's ready in GeneXus, and you don't need to changes. Everything is done automatically. GeneXus 18U3, well, we added deploy sources. The only thing we could do it was deploy and the compile code. Now we can take up the sources as well. This is something that many companies asked for, particularly big companies who before compiling would like to run some classes of static games to see how the code is written, whether there's any security. And so deploy source allows us to do that. and it's easy to set up and send to compile everything that we have compiled. We put Gradle build, and it's done automatically. So these are the reasons why we've changed to Gradle build. GeneXus 18U6, well, we release Spring Boot in beta mode. We need people to test it. I'm available for anyone wishing to try it out for any of the things that you find, and please let me know. Spring Boot generator is going to be our future generator in Java. We created a new property, which is Java framework. Value is none. It goes on working the same way, and we have the Spring Boot option. Not a minor issue is that you no longer have to configure Tomcat. You simply press F5, Spring Boot is downloaded automatically, you put in a package, and when executing, GeneXus would call Gradle run, and then the embedded generator is used. You only have a console where it would tell you that it has just uploaded Spring Boot. In our upgrade of U7, we'll have Java 21 support and Spring Boot 3.2. If we have Java 21, we'll have all the advantages such as best times of performances, and now Spring Boot 3.2, when I change a property, Tomcat with virtual threads instead of the traditional way.
A lo largo de este tiempo, que solamente
we added support for Damen, which is an iOS that is supported in China. Also AWS Lambda serverless. And this is important for cloud computing. Gonzalo Valotti's talk is about that. And read replicas. If I have a large load, I can scale it or horizontally. We added things for open telemetry. Sabrina's talk yesterday mentioned this. And also the PDF box support. At present, any system is using PDF. We had PDF and text support, and so what it did was that higher versions were paid versions, and so we made a new library PDF box that can be used without paying. Now, in the future, we'll be able to have updates. There are many people doing Java 8, but we can't use features of the versions that were released. We'll have to choose a version with data support. Most certainly, if I ask Arwin, he will tell me that you have to go to 18, or I would say 11. You have to do this because I'm sure that you'll have a better performance by updating the data machine. Everything is going to be much faster. We'll go on focusing on Spring Boot. This is going to be the default version option in the short term. We're going to try and generate native images when we are going to be helping you to define what we had images, reflection, identify them in your code and help you to compile native images. We're going to be working on infrastructure as a code, and this is important in cloud computing. What we want to do is to have some kind of model in GeneXus, in the generator and in IDE, so that we can model infrastructure as a code in GeneXus. And also event-driven. This is used for modern applications to communicate modules. This is what we're talking a lot about. And we want to have it modeled in GeneXus. And of course, we're going to continue updating new versions of Java, new functionalities. We are going to try and have the latest updates and versions. Thank you. I've been telling you the main milestone that made Java to become what it is now. It's a modern and robust platform with a very much engaged community, working very strongly next to Oracle, so that Java at present is at the edge of technology. With GeneXus, we are always going to be engaged with being updated so that you can make use of the entire potential that Java provides users. Thank you.